Now, having seen the previous option, let's continue and take a look at these two next ones, as they are somehow related. But first, let's clarify again that because all this is a quite complex topic to cover for a basic course, we're still doing our best for keeping things as simple as possible, especially when it comes to the structure of a process, address space allocation, and many other elements that may require of their own individual course. So, and for the sake of helping you understanding all this, I have made of course some generalizations. Again, what we have so far is a very broad description of what a process is and how it's organized, but hopefully this will put you in the right track so you can further develop your knowledge in this aspect. And allow me to insist that, although I know this may seem a little bit too complex for an introductory course, understanding what a process is and how to keep it safe is what represents the core of cybersecurity. And we could go as far as saying that if we could guarantee the integrity of a running process in a system, we could in fact guarantee the security of that system. Doesn't really matter if it is a Windows, Linux, or Mac-based system, or even a firmware running in an appliance. So, and with that said, let's take a look at these following options, which unavoidably will force us to go further into exploring the structure of a process. Although, and again, I will try to keep things as simple and easy to understand as possible. Now, the first thing that you may notice is that both these options use the same acronym, and which of course is related to the way in which the memory in the system and processes running in the memory are organized. Again, let's try not to overcomplicate things, but let's however make some remarks. First and foremost, and returning to this first option, randomization for images, for example, doesn't literally refers to actual images, but an image mapped into the memory, and which basically is used for allocating a process in the memory. Or in simple terms, what the address of the process is going to be. Well, now this other option refers to the randomization of the virtual memory allocations, or in way more simple terms, what we could consider the many integral parts of the memory itself, but that at the same time are used for allocating other integrating parts of a process. So, and for understanding this more clearly, let's imagine for a moment that a process is like a puzzle, and that for every piece of that puzzle, there's a designated space in the memory. So, if we change the order of those designated spaces, we will unavoidably change the subsequent order of those pieces. Hence, and instead of directly randomizing the process and its multiple parts, we are randomizing the position of the available spaces in the memory for placing those parts. So basically, it's a randomization method which goes from the bottom up. Again, allow me to emphasize, this isn't the most accurate description of this technique, but it should give you a more clear idea of the difference between these two options. And what's more, it should help you to start having a slightly better understanding of the structure of a process and the way in which this is organized in the memory of the system. So, and having now a more clear idea of what this randomization means, let's take a look at this following option, which as we can see, it once again shares the same acronym. Although this option isn't that complex, as it only increases, so to speak, the level of randomness in which the virtual memory, or that being in the first place randomized by this other option, is arranged. But now into the more complex part. What's the purpose of this option? I mean, if the virtual memory is already being placed in a random manner, what's the reason behind using an even higher level of randomness? Well, the reason is because, and just like with the first option we saw, or data execution prevention, these two protection measures have already been figured out by hackers. So having either the process or the virtual memory arranged in a seemingly random way is just not enough. But of course that begs the question, if everything is placed in a random position, then how could anybody ever be successful when trying to inject certain parts of a process, or the virtual memory for that matter? Well, the answer is quite simple. You just try a lot of times. Yes, that's right, you just perform the attack again, and again, until eventually you hit the target. And actually, this is what's called a brute force buffer attack, although it also has other names, depending on the specifics of the attack or which area of either the memory of the process is being attacked. But for the time being, and in simple terms, this just means that the hacker will attempt to perform the attack more times than all possible combinations that could come from these two protection methods. Now, this leads us into more complex topics, of course, but some of them actually help us to answer simple questions, such as, what's the difference between using a 32-bit operating system versus a 64-bit one, in terms of security, of course? Well, this is one of the major differences. A 64-bit operating system or process will tend to have more potential combinations when it comes to randomizing the virtual memory. So, we can confidently say that a 64-bit process provides more security than a 32-bit one. Of course, that's not to say much, because nowadays that's not a great obstacle for a competent hacker. But again, every little bit helps. So, and back to this option. Now we can see why a higher level of entropy when randomizing the virtual memory is needed. And which again will make things more difficult for the hacker, but not in any way an unsurmountable obstacle. Now, I know that things may look a little bit too complicated at this point, but don't worry, they are about to become even more complicated, because now we need to take a look at this other option, and which again will make us go a little bit more deeper into the structure of both the process and the virtual memory of the system. Moreover, it will help us to understand more clearly what actually happens when a hacker injects code, as we have been calling it, into a process or the area of the memory occupied by that process. See you in the next video.